Okay, so today we're going to go over the exam and what to kind of expect from it. Before I start, are there any questions from either exam review or test review? Sorry. Okay. So you have no homework tonight. You just need to study for the test. The test comes with a formula sheet, but it is not. I don't want to say this exhaustive. It doesn't cover every single formula that you've seen. It will say one example of a law of cosines formula, one example of a law of sines, and it'll give you Heron's formula, but not the semi-perimeter. It'll just be square root of s times s minus a. So, no. It'll give you one cosine formula. But you can get the other from. Yeah, but it's the same. So squared plus c squared minus 2a 2bc cosine a. Right, to get the other one, you just swap these terms and divide by 2bc. So when you swap that, you get 2bc cosine a squared plus c squared minus a squared. And then dividing it by 2bc gives you the alternate form. And you can do this with all of them. So you're just getting the regular cosine formula, this right here. But yeah, any specific problems that y'all wanted me to go over or talk about? The area one? Yeah. The two triangles in one, do you mean the it's like this? Is it the one where you have to like that one? Oh, okay. Like that. Okay, cool. So let's start with the house one, and then we'll go to that one. Okay. So the house problems that ask you whether or not a painter has enough paint can come in two varieties. The first is that it gives you the angle of the roof, and then it gives you the side of like 22, right? 14, whatever this is. Okay. The second variety is when they actually give you the bottom length of the house. So something. Sometimes I amaze myself at how good at drawing I am. It's incredible. Wow. I should have. Okay, so 22. It's 28. Why not? Okay. So, right. In these two problems, we're solving for the same exact thing, which is just the area of the entire shape. We just go about it two different ways, right? On the right, we're given the two lengths of our box, if you will. So that makes that step a lot easier, right? Because what's the area of this box? Exactly. So we just type 22 times 28 into our calculator, and that's our area. Now, when we talk about the second area right here, there you go. Yeah. So the area of the triangle is going to be found using Heron's formula. So we move that 28 up here because it is a box. This length is going to be the same as this length. And Heron's formula requires you to find the semi-perimeter, which is half of the total perimeter, right? So we do 14 plus 14 plus 28, which is going to give us Is that 28? 28, exactly. Actually, this triangle doesn't exist because I made it up. It's a triangle with area of 0 because Heron's formula is square root of s times s minus a times s minus b times s minus c. So I would have to change that side to like 26 or something like that. Maybe that would work. Right? Would 26 work? 28 plus, yeah. Yeah. But then 20, yeah. So yeah, we'd be good. So if we change that to 26, let's just go ahead and do that. Since this actually works. Six. So that means that the sum divided by 2 is going to be 27. So then plugging that in, that'll give us an actual area. So again, the only reason why I'm redoing it is because that side gave us a 0 here, which gave us a 0 for the area. Which means it's not a triangle. Oh, again, sorry. Wait. Thank you. So 20, this is 27 minus 26, and this is 27 minus 14. I have the squared here because we have 2 of the same sides, so just makes it a little bit shorter. Okay, now let's look over to our, the answer to this is going to be the sum of the areas. So the answer is going to be AB plus A2. But all the work goes into finding those two things. Yeah, Mason. Yeah, it does. I round that up. So on the left one. Okay, so on the left-hand side, what's the first thing that we want to do? You have 2 options. Jacob, what do you want to do? Sure. All right. Let's talk about the line right here. Find that line. So, or you could just find the area first, right? But either way, you do have to eventually solve for that side length, right? So, you can actually use the law of sines. You could use cosine or sines here. Right, and the only reason why that works is because this is an isosceles triangle. Because both of these lengths are the same. You don't have to solve it this way, it's just one of the ways you can solve it, right? You could have used the law of cosines or, you could use law of cosines or this law of sines. So you'll find that theta is just going to be, like he said, 180 minus 110. That gives you 70, but then you divide that by 2 to get 35. So now the area of the triangle can be found by doing what? Actually, hold on. I'm skipping steps. Sorry. Okay, let's call this side length C. Just, right. Does that make sense? Okay, Jacob. You good? Okay. Yeah. So in this case, I don't know. What do you get for C? Does anybody have a calculator out? Valid. So it should be somewhere in like the 30s. I don't know, maybe it's not the 30s. 22.93, really? It's just surprising. It's just, I don't know. I didn't expect it to be that low. Oh, wait, this isn't degrees. We're not solving for the angle. Hold on. That's okay. We'll do that. Okay, so now instead of the box area being 22 times 28, it's 22 times whatever length we just solved for. So that's 22.93. And our area doesn't have to be necessarily derived from Heron's formula. We can use the log, well, not the logs, it's just area formula with sign in it. And that's 1/2 14. I got it, Jacob. 1/2 14 times 14 times sine of 1/5. AT, yeah. You add both of these together. So the answer is still the sum. Any questions about this? They're the same type of problem. You just get different initial data, if you will. In one, you get all the sides. In the other, you get, 3 sides and 1 angle. S is the semi-perimeter, so this isn't the area. This is something that we use to get the area. This is still in units of feet, so it's not technically an area. Does that make sense? That's what we did. No, because so this isn't an area. You might have. Okay. Okay. Yeah. So the last question that I think we need to go over is just the one with the 2 different vantage points on the same object. So if we're looking like this, let's go this way. And we have the distance between 2 points A and B that we're looking at this object from. And we know that we're a distance away from it, x. How do we find how tall it is? So the roll has ceased. So, as Jacob was saying, that is going to be the form of your final answer. However, the way you get that is worth explaining. So, when we have tangent of our smaller angle, the opposite side to this in the bigger right triangle is going to be h, whereas its adjacent side is going to be 1300 plus x, because that's its total distance from the observation point to the object, right? So we have tan theta s is equal to h over 1300 plus x. And when we do the same thing for the bigger angle, we're going to end up with tan of this bigger angle, theta b, is equal to h over x, since now its adjacent side is just x. Right. Going through the algebraic steps, we want to multiply things across, solve for x, and then equal those x's to each other and solve for h. After doing all of those steps, we should end up with h is equal to 1300 tangent theta s times tangent theta b divided by tan theta b minus tan theta small. And when you type it in your calculator, you have to be careful of these parentheses at the bottom. The top doesn't need any parentheses. You can just multiply those across. But as soon as you hit the divide symbol, make sure you open up a bracket or parentheses. Type the tan minus tan, and then close the parentheses. Okay. Yeah, so going through those steps more explicitly, I'll just move this over. So we multiply the 1300 plus x across to get 1300 tan theta s. H, and then we have I just cross multiply that one, and it's a lot easier. Yeah. This one takes a couple more steps. We have to subtract over the 1300 and divide by tangent theta s. So we have x is equal to h minus 1300 tangent theta s, all divided by tangent theta s. So that way now when we equal them to each other, we have two different fractions that we can cross multiply. So we have h minus 1300 tan theta s and then cross multiplying gives us, shouldn't take much longer, 1300. Did that correctly? Yeah. You swap these terms, factor out an h. That gives us h tan theta b minus tan theta s. And as you can see, when I divide both sides by tan theta b minus tan theta s, we get exactly what I had written before. And there it is. Cool. Very cool. All right, any last questions about the test? It's 22 questions. It's going to be printed out. Where it gives you a equals what? Right, the one where you have, so you're actually using the law of signs on that one, where, so like a is equal to 4, b is equal to 6, and a is equal to, I don't know, 37 degrees. So when you set this up using the law of signs, you'll solve for sine of b. I actually don't know. my calculator for this. So 6 sine 37 divided by 4. So this is 0.902. So sine B is somewhere between 0 and 1, which meets the conditions of having either one or two solutions, right? Okay. When it's between 0 and 1, it always has one solution. And the way we find that is just by doing the inverse sine of whatever sine B is. And in this case, we get 64 degrees. So that means that B1 is equal to 64 degrees. That's 5.2, but whatever. Okay, so B2 is always possible. And we can find it by just doing 180 minus B1. Now, it's, I don't know why I need to type this in my calculator. It's 115.48. 115.48. I think that's right. So now that we have this, we need to compare that to A. And it turns out that 115.48 can add to A and still not break 180, meaning we have two triangles. So we have two solutions. Now, kind of the trick to knowing whether or not you have two solutions or one solution without doing like any additional math after B1 is you just compare their size. If B1 is greater than A, then 2. So then you have two triangles. If it's not, then you don't. Then you only have one triangle. If B1 is less than A, then 1. Yes. So if sine B is equal to 1, remember that that means it's a right triangle, and that's always just one solution. And if sine B is outside of the range, then there's no triangle. I don't know how to write that. Sine B is bigger than 1 or less than -1. There's a triangle. What's up? So let's talk about the exam then. All right. So your exam is going to be 35 questions. It's going to be printed out. And you are going to have a formula sheet. Formula sheet. So this formula sheet, I believe, is going to be the same formula sheet that you get on your test. I didn't feel like making multiples, so. Yeah. Shouldn't take you the entire period, but I made it short enough to where if you do take longer on some of these problems, you should have enough time. You know, if you do need to take your time on it, you should be fine. And the material goes from 7.3, which is going to be composite functions, or no, 7.3 is inverse functions, and goes all the way to, well, it skips chapter 8. And it goes all the way to all of chapter 9. So 7.3 all the way to the end, skips chapter 8, and then goes through chapter 9. Yeah. If I recall, it's pretty nearly a 50-50 split as far as like chapter 7 versus chapter 9. I think. But I know timing factored into it because chapter 9's questions are timed as like taking longer. I had some issues with that. So it'll all be problems that you've seen before. Wait, what did you ask me? Wait, what are you talking about? What my math up? Oh, okay. I thought you were asking if the exam was my math lab. Okay. So yes, there will be an exam review, right? It's going to be optional, and it will be for bonus points. But it's not going to open up until after your exam. Or, sorry, not after your exam. After your test. So it's not going to open up until after your test tomorrow. Yeah, that wouldn't make any sense. That wouldn't make any sense. So yeah, after you take the exam, you can do a review, just to, That's what I'm trying to do, but we'll see. So, what? I don't know. I like the AB day. Do y'all like that? No? You don't like that? Would y'all want to do like dodgeball captains and pick teams? Yeah. Yeah, we can maybe try a draft as long as it doesn't get too crazy. All right. Let's talk about inverse function, guys. Oh, that was a voice crack. So remember we started 7.3 this quarter with inverse functions, and inverse functions were created from truncated versions of our normal functions, sine, cosine, and tangent, right? So these inverse functions had domains that were the outputs of our functions, sine, cosine, and tangent. Those domains were -1 and 1 for inverse sine, same for inverse cosine. But tangent was -infinity to infinity because its vertical asymptotes became horizontal asymptotes. Asymptotes, yes. Yes. So its domains were these, and its ranges, what the outputs were, was the restricted domain of our regular function. So it was -π/2 to π/2 for sine. Zero to pi for cosine, and -π/2 to π/2 for tangent. Say again? No, this stuff you need to know for the exam. So chapter 7 was probably the roughest grade on average from all my classes. So you'll need to review that and study that. Exactly. Mm-hmm. Just like the graph, these domains and ranges swap, right? All the x's become y's. Yeah. And we actually use that. Yes, Mason. I was going to say we actually use that to our advantage to solve problems like tan inverse of 1. You want to talk to me about that after? We'll talk about it. So tan inverse of 1, right? What does this mean? How do we put this in a way that makes sense? Well, we can use the fact that we can swap this to a regular tangent function and then look at all the tools at our disposal. So we can rewrite that as tangent theta is equal to 1. And now all we're looking for is an angle that when we evaluate tangent of it, we get 1. And we have a lot of tools to do that with, right? We have special right triangles. We have the unit circle. We have those tables that were in my notes in the e-text that you may or may not have crammed the night before into your memory. But it all went away, as it does. So we can draw a special right triangle like the one I just did and see that tangent of π/4 gives us 1. And in fact, this is the answer. So the inverse tangent of 1 is π/4. And this is something that you should be careful of, right? So when you have an inverse tangent or an inverse sine, just inverse functions in general always give angles as your answer. One common mistake I saw was that a lot of people, especially when we talked about composite functions, would only do half of the function. They should have given me an angle and they gave me a number, and vice versa. You will, but I'm going to make a comment on the exam. Well, it's broken down by section. So you used radians for chapter 7 and you used degrees for chapter 9. So at that switching point, when the questions go from chapter 7 to chapter 9, I'll have a little note in there, like switch calculator to degrees. Yeah. Okay, so what happens when we combine tangent inverse with just another regular function? We learned about things called the cancellation equations, right? So things like sine inverse, sine of pi over 2. The cancellation equations had two requirements. One of them was that it was the same function, and we see that is the case here. The second requirement was that the inner function, its input, was within the domain of this inner function. So is pi over 2 in the domain of sine? You just check up here. Yes, pi over 2 is in the domain of sine. So the answer is just pi over 2. Right. However, if they didn't satisfy one or both of these conditions, we had to do extra work, right? So an example would be something like this. Cosine inverse of cosine 5 pi over 4. Now is 5 pi over 4 in the domain of cosine? Definitely not. I don't know. What is everyone else doing? Some of y'all are asleep. Some of y'all are, and thank you. Some of y'all are like staring at your laptops. Some of y'all are writing things down. I have no idea what y'all are doing. Somebody has a blank desk. Like, I don't know. I don't know. I don't know how y'all are remembering this for the exam. What'd you say, Spencer? The answer would be 3 pi over 4. Could you enlighten us how you found that? 2 pi, you mean?
Yeah, pi 2.
But why does that work? So taking 5 pi over 4 and subtracting 2 pi. True. Yeah, this is a periodic shift right here. Right. Quadrant 2. Pi minus pi over 2. Wait, pi minus your angle. Okay, so what I'm trying to get at is if we do the minus 2 pi, right? You're trying to do two different methods, right? So this is correct, right? This is good. But the reason why this works is because cosine is an even function, which means what? What does that mean? It just gets taken away, right? So this is the same thing as cosine of 3 pi. Sine, the negative gets put on the outside because it's odd. Yeah.
Yeah.
Mason? I'm sorry. Because that's the period of our function. So with trig functions, right, whatever the period of of the function is, you can always add or subtract it to your input, and you'll get the same exact output because they look like little waves. I'm so good at drawing. Look at that. Look at how accurate that is to a sine function. Wow. But no, it's because they're like this. Every kind of output is exactly the same distance away. Every single one. No, the answer is 3 pi over 4. Guys, I don't know why this happens. We just got so distracted. I'm answering like 10 different questions about the same, like, I don't understand what's happening. I'm just trying to do this problem, right? Mason asks a good question. Why am I adding 2 pi, right? And then everybody just goes and diverts in their own conversation, okay? So, going back to this, right? When we subtracted 2 pi, we got negative 3 pi over 4, which is going to give us the same output as cosine 5 pi over 4. And we can use the even property of cosine to get 3 pi over 4. So then we substitute cosine 3 pi over 4 back into our problem. And is 3 pi over 4 in the domain of cosine? Yes. So that means I can use the cancellation equation to get my answer of 3 pi over 4. Yes, Jacob. Again, that's why I sit here and I try to explain it, right? No, the I'm so confused comment. Go, Jacob. I know you didn't. Okay. What? Exactly. So chapter 7, you always want to be in radians, but in chapter 9, you want to switch that to degrees. Yeah. Yeah. No, you're good. Yes. So, where was I? Right. What happens when we have things that, instead of just not being in the domain, we don't have the same function? So something like sine inverse of cosine of 3 pi over 15. 3 pi over 15 is in the domain of cosine, so that's not the issue. The issue is that we have sine inverse and cosine together. So what do we do? Nope. Not even. Nope. It's already in the range, right? 3 pi over 15, that's in between 0 and pi. Nope. Can we ever write cosine in terms of sine? Cofunctions, right. The cofunction identities tell us that cosine of some random angle theta is the same thing as pi over 2 minus, or sorry, theta, pi over 2 minus theta. I did. Pi over 2 minus theta. Take it. Simplify it. So when we rewrite this, we do get, so it's going to be pi over 2 minus 3 pi over 15, which does simplify to 3 pi over 10, and that is in fact our answer. All right, guys, that's it for today. Tomorrow, you'll have your test. Friday, we'll do another review, and then the exam.